was correlated with, it wasn't causal necessarily, but was correlated with the ability to sustain higher levels of pain than people who were in more typical non-obsessive forms of love, long-standing relationships where there wasn't obsessive love, rather. And of course, in this study, there were a lot of good control groups. They included distractor. They included people obsessing about other things, their pet, etc. They included other forms of love and attachment. But it does seem that certain patterns of thinking can allow us to buffer ourselves against the pain response. And that should not be surprising. Certain forms of thinking are associated with the release of particular neuromodulators, in particular dopamine. And dopamine, it may seem, is kind of the thing that underlies everything, but it's not. Dopamine is a molecule that's associated with novelty, expectation, motivation, and reward. We talked about this at the beginning of the episode, that it's really the molecule of expectation and motivation and hope and excitement more than it's associated with the receival of the reward. Well, dopamine is coursing throughout the brain at heightened levels and coursing throughout the body at heightened levels when we fall in love. This probably has some adaptive mechanism that ensured pair bonding between people, or who knows, maybe it ensured not bonding to multiple people. Nobody really knows how dopamine functions in terms of pair bonding, but it is known that when people fall in love, new relationships create very high levels of dopamine, and that's probably the mechanistic basis by which these people were able to buffer the pain response by thinking about their partner or this new relationship that they're in almost obsessively or obsessively. Now that raises a deeper question. We should always be asking, yeah, but how? Well, the dopamine system can have powerful effects on the inflammation system. And it doesn't do this through mysterious ways. It does this by interacting through the brainstem and some of the neurons that innervate the spleen and other areas of the body that deploy cells to go combat infection, inflammation, and pain. And the ways in which dopamine can modulate pain, and in this case, this particular study, transform our experience of pain, maybe even into something that's pleasurable, is not mysterious. It's really through the activation of brainstem neurons that communicate with areas of our body that deploy things like immune cells. So for instance, we have neurons in our brainstem that can be modulated by the release of dopamine. And those neurons in the brainstem control the release of immune cells from tissues like the spleen or organs like the spleen. And those immune cells can then go combat infection. We've heard before that when we're happy, we're better able to combat infection, deal with pain, deal with all sorts of things. It essentially makes us more resilient. And that's not because dopamine is some magic molecule. It's because dopamine affects particular circuits and tells, in a very neurobiological way, in a biochemical way, tells those cells and circuits that conditions are good. Despite the fact that there's pain in the body, conditions are good. You're in love, or conditions are good. You want to be in this experience, or conditions are good. This is for a greater cause, that you're fighting or suffering for some larger purpose. So all of that has existed largely in the realm of psychology and even motivational literature and this kind of thing. But there's a real mechanistic basis for it. Dopamine is a molecule that can bind to receptor sites on these brain areas. Those brain areas can then modulate the organs and tissues of the body that can allow us to lean into challenge. And those challenges can be infection, it can be physical pain, it can be long bouts of effort that are required of us. And I think many people have described the feeling of being newly in love as a heightened level of energy, a capacity to do anything. I mean, the whole concept of a muse is one in which some individual or something, either imagined or real, enters our life, and we can use that as fuel. And that fuel is chemical fuel, and that chemical fuel is dopamine. And it really does allow for more resilience and can even transform the experience of pain, or what would otherwise be pain, into an experience of pleasure. So along those lines, let's talk about pleasure. With all the cells and tissues and machinery related to pain, you might think that our entire touch system is designed to allow us to detect pain and to avoid tissue damage. And while a good percentage of it is devoted to that, a good percentage of it is also devoted to this thing that we call pleasure. And that should come as no surprise. Pleasure isn't just there for our pleasure. It serves an adaptive role. And that adaptive role relates to the fact that every species has a primary goal, which is to make more of itself. Otherwise, it would go extinct. That process of making more of itself, sexual reproduction, is closely associated with the sensation and the perception of pleasure. And it's no surprise that not only is the highest density of sensory receptors in and on and around the genitalia, but the process of reproduction evokes sensations and molecules and perceptions associated with pleasure. And the currency of pleasure exists in multiple chemical systems, but the primary ones are the dopamine system, which is the anticipation of pleasure, and the work required to achieve the ability to experience that pleasure, and the serotonin system, which is more closely related to the immediate experience of that pleasure. And from dopamine and serotonin stem out other hormones and molecules, things like oxytocin, which are associated with pair bonding. Oxytocin is more closely associated with the serotonin system biochemically and at the circuit level, meaning the areas of the brain and body that manufacture a lot of serotonin. Usually, not always, but usually contain neurons that also manufacture and make use of the molecule oxytocin. Those chemicals together create sensations of warmth, of well-being, of safety. The dopamine molecule is more closely associated with hormones like testosterone and other molecules involved with pursuit and further effort in order to get more of whatever could potentially cause more release of dopamine. So this is a very broad strokes, no pun intended, description of the pleasure system. There are, of course, other molecules as well. One in particular that's very interesting is something called PEA. PEA stands for phenylethylamine, sometimes also referred to as phenylethylamine, depending on who you are and where you live. How you pronounce it doesn't really matter. PEA is a molecule which is incredibly potent at augmenting or increasing the activity of certain cells and neural circuits that relate to the pleasure system. PEA has purportedly been thought to be released in response to ingestion of things like certain forms of dark chocolate. Some people take it in supplement form. It's a bit of a stimulant, but it also seems to heighten the perception of pleasure in response to a particular amount of dopamine and or serotonin. So for instance, in a kind of a arbitrary experiment and units type example, if a given experience evokes a particular amount of serotonin and dopamine and gives rise to a subjective experience of pleasure of, say, level 3 out of 10, the ingestion of PEA prior to that experience can increase the rating of that experience as more pleasureful, maybe a 4 or a 5 or even a 6. And PEA is known to be present in, or I should say its release is stimulated by a number of different compounds, such as dark chocolate. Certain things like aspartame in certain people can actually increase the amount of PEA released. Some of these glutamate-related molecules like aspartame or things that are in the glutamate pathway can increase PEA release. And then some people will actually take PEA in supplement form for its mild stimulant properties, as well as for increasing the perception of or the ability to experience pleasure. It's not a sledgehammer. It's not like dopamine itself. People that take things like mecunopurines, L-Dopa, or drugs of abuse, which I certainly don't recommend, things like cocaine or amphetamine, experience tremendous increases in dopamine, not so much increases in serotonin. Some people will take serotonin in precursor form like 5-HTP or serotonin itself, or they'll take the amino acid precursor like tryptophan. I'm not saying these things as recommendations for increasing one's sense of pleasure. I'm describing them because of what they do generally falls into two categories. The first category is to raise the foundation, what we call the tonic level of dopamine and serotonin. So if levels of serotonin and dopamine are too low, it becomes almost impossible to experience pleasure. There's a so-called ahedonia. This is also described as depression, although it needn't be long-term depression. So certain drugs, like antidepressants like Wellbutrin, bupropion, as it's commonly called, or the so-called SSRIs, the serotonin selective reuptake inhibitors, like Prozac, Zoloft, and similar, will increase dopamine and serotonin respectively. They're not increasing the peaks in those molecules, what we call the acute release of those molecules. What they're doing is they're raising the overall levels of those molecules. They're raising the sort of foundation or the tide, if you will. Think about it as your mood or your pleasure, rather, is like a boat. And if it's on the shore and it can't get out to sea unless that tide is high enough. That's kind of the way to think about these tonic levels of dopamine and serotonin. Now, most of us, fortunately, do not have problems with our baseline or our tonic levels of dopamine and serotonin release. Things like PEA in that case will cause a slight increase in that tide and make the ability of certain experiences to increase dopamine further more available. What we call this in neuroscience is so-called gain control. It can kind of turn up the volume, bring us closer to the threshold to activate certain circuits. And this is really what we mean when we say a neuromodulator, okay? This is why when you are very happy about something, let's say you're out with your friends, you're really excited, maybe depending on where you live and what's going on in your area of the world right now, like I have a niece and she's been locked up in quarantine for a long time recently because it was deemed safe. She got to go to summer camp. I have never seen that kid so happy to spend time with her friends. She was so excited, and it was really amazing to see how excited she was. Her baseline levels of dopamine were clearly up, so much so that when she saw her friends, she literally started squealing. Okay, they were squealing. She was squealing. Everyone was squealing. I wasn't squealing. I would admit it if I was squealing. I wasn't squealing, but it was such a delight to see, and I'm sure that made my dopamine levels go up, she was just so excited such that anything and everything felt like an exciting stimulus. This is pleasure, right? And I don't want to write off the experience from a neurobiological reductionist standpoint. Quite the opposite. It's really beautiful to see, again, this principle that different experiences and the experience of pleasure from different things, seeing your friends for the first time, summer camp for a kid, whatever it might happen to be, use the same currency, dopamine, use the same currency, serotonin. And this is a principle that I hope in listening to this podcast and even some of its repetitive features from one episode to the next, I'm hoping that those will start to embed in your mind that the brain and body use these common currencies for different experiences. So yes, if your dopamine and serotonin, or I should say if your dopamine and or serotonin levels are too low, it will be very hard to achieve pleasure, to experience physical pleasure or emotional pleasure of any kind. That's why treatments of the sort that I described a minute ago might be right for you. Obviously, we can't determine if they're right for you. It's also why they have side effects. If you artificially increase these molecules that are associated with pleasure, oftentimes you get a lack of motivation to go seek things like food. People don't get much interest in food because why should they if their serotonin levels are already up? Again, there's a ton of individual variation. I don't want to say that these antidepressants are always bad. Sometimes they've saved lives. They've saved millions of lives. Sometimes people have side effects that make them not the right choice. So it has to be determined for the individual. Things like PEA are a more subtle effect. I should mention PEA supplementation is something that a number of people use, but it's very short-lived. Because of the half-life of this molecule is very brief, the effect only lasts about 20 minutes or so. Things like L-DOPA, mecunapurines, lead to longer baseline increases in dopamine. But remember, anytime you raise a baseline, you reduce the so-called signal to noise. What it means is if you're riding around at really high dopamine, at first, everything will start to seem exciting. Like my niece and seeing her friends for the first time, everything's exciting. But then what will happen is when your dopamine levels return to more normal levels, it will take a much greater dopamine increase, a much bigger event, more novel, more exciting, in order to achieve the sense that what you're experiencing is pleasureful. And this is because of the relationship between pleasure and pain. Now, in a future episode, we are going to go deep into this relationship between pleasure and pain. But just briefly, as a precursor to that, and because it's relevant to the conversation that we've been having, you might want to be wary of any experience, no matter how it arrives, chemical, physical, emotional, or some combination. You might want to be wary of letting your dopamine go too high And certainly you want to be wary of it going too low because of the way that these circuits adjust. Basically, every time that the pleasure system is kicked in high gear, an absolutely spectacular event, you cannot be more ecstatic. There is a mirror symmetric activation of the pain system. And this might seem like an evil curse of biology, but it's not. This is actually a way to protect this whole system of reward and motivation that I talked about at the beginning of the episode. It might sound great to just ingest substances or engage in behaviors where it's just dopamine, 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 and just constantly be motivated. But the system will eventually crash. And so what happens is when you have a big increase in dopamine, you also will get a big increase in the circuits that underlie our sense of disappointment and readjusting the balance. And with repeated exposure to high levels of dopamine, not naturally occurring wonderful events, but really high chemically induced peaks in dopamine, high magnitude chemically induced peaks in dopamine, what happens is those peaks in dopamine start to go down and down and down in response to the same what ought to be incredible experience. We start to what's called habituate or attenuate. And yet the pain increases in size. And this has a preservative function in keeping us safe, believe it or not. But what I just described is actually the basis of most, if not all, forms of addiction, something that we will deal with in a future episode in depth. So what should you think about all this? How should you think about pleasure and how should you think about pain? What is too much pleasure? Well, that's going to differ from person to person, but to the extent that one can access pleasure repeatedly over time, ideally without chemical augmentation, certainly not excessive chemical augmentation, that means that this pleasure system is tuned up well and can continue to experience pleasure. However, if you find yourself engaging in the same behavior over and over again, but achieving less and less pleasure from it, chances are you want to adjust down how often you engage in that behavior, and or adjust down your expectation of reward every time you engage in that behavior. What do I mean by that? Well, at the beginning of the episode, I talked about how dopamine will allow us to get into bouts of hard work. We will work very hard to pursue a reward, and that's really what dopamine does. And then when the reward comes, that doesn't increase our dopamine. In fact, our dopamine levels go down. One of the key things that we can all do to adjust our ability to experience pleasure is to engage in that intermittent reward schedule. You can either adjust down the peak in dopamine, meaning not let yourself ever get too happy, but that's no fun, right? Life is about occasionally achieving or experiencing ecstasy, but every once in a while, remove the reward. And of course, I don't mean ecstasy, the drug. That's a separate matter. The MDMA trials are a separate matter. Very interesting. I want to be clear. I meant psychological and physical ecstasy of the natural sort. I have immense interest in what's going on in the MDMA trials, but just for clarity purposes, that's a separate topic that we will cover in an episode, very soon. So how do you adjust this dopamine system? Well, every once in a while, at random, not in a predictable way, you remove the reward. And that will keep you and your dopamine system tuned up in the proper ways. The gain of the dopamine system, as we say, will be adjusted so that you can continue to experience dopamine and serotonin when you actually get the reward. This can be translated into a huge number of different domains, but I want to give some examples because I'm sure that many of you are asking, wait, what does this actually mean? Okay, let's say you're a student, or this could be a student in academia, or this could be a student of a physical practice. Every once in a while, when you do something really well, maybe that's even just showing up to the practice, rather than pat yourself on the back, just tell yourself, yeah, that's the minimum that's expected of me. When everyone's excited about something that you're doing, maybe you're excited about it, try and adjust down your excitement a little bit. I know this might seem counterintuitive, but you're preserving the ability to experience excitement in a variety of contexts. Let's say you get a big monetary award. Well, that's great. I'm happy for you, and that's wonderful. However, you should be a little bit wary if you care about your dopamine system and you care about your ability to get subsequent monetary rewards, doesn't matter which. through effort, if you want to be able to maintain the ability to exert effort, well, then you probably wouldn't want to run out and immediately buy something with that monetary reward. In other words, you wouldn't want to layer on more dopamine release. Okay? You might, but you might not. You might skip it. What you'll find then is that your motivation is essentially infinite. This is what I described at the beginning of the episode. And again, it's because dopamine is this currency. It's like these days you hear a lot about Bitcoin and Ethereum and Dogecoin and US dollars and euros and all this other stuff. But the currency that you use in your body doesn't matter what external currency those are. In fact, as you watch the value of different currencies go up, whether or not it's cryptocurrency or standard currency, the value is actually reflective of the dopamine that exists inside of people, right? So all the excitement about a particular currency, crypto or otherwise, is really just dopamine. That's the currency that we all use. And there's no negotiating that. That's just the way that we're built. Now, to give yet other examples, let's say you're teaching other people how to do something and they do something exceptionally well. If you reward them every single time, and in particular, if you reward them with something that's even greater than the experience of what they did. So let's say kids win a soccer game and they're ecstatic. They're jumping all over the place. They're super excited. And you reward them with an even bigger experience, a celebration. You are actually inhibiting their ability to perform the same set of activities that led them to the win if, and I really want to underscore, if you reward them every time. Of course, we should reward kids and each other and ourselves for our accomplishments, but you don't want to do it every time. And sure, there will be some disappointment from suddenly removing the reward that you expected, but that's exactly the point. That's what keeps these circuits tuned up properly. Now, there's the other form of pleasure, which is the more immediate, visceral, or sensory experience of pleasure. This is distinct from goals and goal-directed behavior. I'm talking about the immediate experience. This is more of the serotonergic system. There are other systems involved too, but this is also the system that draws out those endogenous opioids from a particular structure. We have a structure in the back of our brain called PAG, P-A-G. It's the periaqueductal gray area. Very interesting brain area that is associated with pain, but also with pleasure, because under certain conditions, it deploys endogenous opioids and gives us a kind of blissed out feeling. Okay, this is not like the opioids of the opioid epidemic sort that people take and unfortunately have led to tremendous amounts of suffering and abuse. These are endogenously released opioids. These are the kind of opioids that come out from long-distance bouts of physical exercise and running. These are the opioids that are deployed in response to giving birth and overcoming the tremendous pain of childbirth. So PAG is very contextual, and there are a few types of stimuli, or I should say events in life. I'm really showing my nerdy side. There are a few types of stimuli, or I'm talking about experiences, that evoke endogenous opioid release from PAG. One is sexual activity. Sexual activity can increase pain threshold. And here I am not suggesting or getting involved in anyone's particular proclivities or personal experiences. You're welcome to editorialize this however you like. However, what I'm talking about are animal data, and yes, human data as well, that show that pain thresholds are increased anytime PAG is activated because of the release of these endogenous opioids. There's also the immediate experience of whether or not a particular form of touch is pleasurable or not. And there's some very interesting biology that relates to really how those little wires from those DRGs innervate our skin. Studies, I should say, done by David Ginty's lab at Harvard Medical School. The Ginty lab has spent years working on the somatosensory system, the touch system, has identified a particular category of neurons that innervate the skin, and then those neurons, of course, send that information up to the brain too, and they actually respond to direction of touch. Now, some of you might be more sensitive to this than others, but it turns out that certain hairs like to be deflected one way versus another. Whether or not you like cats or not, you can do this experiment. You can pet a cat in the direction that their fur lies. So it lies down in a particular direction. You'll notice that there's actually a gene that dictates that the hairs lie down in a particular direction. And if you pet them in a way that's cooperating with that direction, so not pushing the hairs up, but rather stroking the hairs on the back of the cat, what you'll notice is they often like that. Not all cats. Some cats are pretty grouchy, but if you stroke their hair, they will often purr, they'll often push into you. If you were to stroke their hair in the opposite direction, pushing the hairs up against the direction that they want to lie down, cats do not like that. And it turns out people don't like that either. Some people do like to have their hair pushed in a direction against the direction in which it wants to lay down, but there is more typically a response of feeling like it's pleasurable for instance, when someone brushes or combs their hair in the direction that it wants to lay down. And that's because the way in which these neurons that innervate these hairs sends information up to the brain, bifurcates actually. It splits into brain centers that evoke a sense of pleasure or a sense of not pleasure. It's not necessarily pain. So you might find that certain people are very particular. They like to be touched in a certain way, but not others. You might be one of those people. And areas of our skin that have high density of receptors are very, very sensitive in a real way, in the real sense of the word, to patterns of touch and whether or not a touch is too firm or too light. And that will be modulated by overall levels of arousal. And when I talk about arousal, what I'm talking about is how alert or how sleepy we are. It is impossible to experience pain when we are deep in sleep. I don't mean sleeping like of the typical night sort. I mean of the anesthesia sort. That's the purpose of anesthesia, to bring the brain and body into a deep plane of rest, very deep in fact. And it's very hard, if not impossible, to achieve or experience pleasure when we are in a very low state of arousal as well. When we are in heightened states of arousal, we can achieve pain, we can experience pain, and we can experience pleasure, okay? And under those heightened states of arousal, we are more sensitive, literally, the passage of electrical signals from those locations on the body that have heightened degrees or higher degrees, I should say, of receptors. Use your imagination. They include the lips, the face, the feet, and the genitals, and nearby areas, literally nearby areas. Under conditions of high arousal, two things happen. The ability to achieve or experience pleasure at those locations goes up, and our tolerance and our threshold for pain also goes up. So the principle here is that as our levels of arousal, that foundation of arousal goes up or down, so too goes up and down our ability to achieve pleasure and pain. And so these two extremes of being deep within anesthesia, or another extreme is asleep or in heightened levels of arousal, our ability to achieve pleasure and pain are going to scale according to those. And this is why, and I'm certainly not suggesting this, but this is why some people will take stimulants or drugs of abuse that increase arousal in order to achieve pleasure of other kinds. The problem is that those drugs, in particular things like cocaine and methamphetamine and amphetamine, become their own form of reinforcement, so much so that the person doesn't seek out any other form of excitement or arousal. Okay? So today we weren't talking about addiction. We weren't necessarily talking about motivation, but we touched on those topics as sort of a precursor of what's to come. We talked about the pathways in the skin and in the brain and elsewhere in the body that control our sense of pleasure and pain. We described a number of different tools ranging from hypnosis to different supplements to electroacupuncture and various other tools that one could use to modulate your sense of pleasure or pain. And of course, in thinking about pleasure, we have to think about the dopamine system and the serotonin system and some of the related chemical systems. I realize that today's podcast had a lot of scientific details. We've timestamped everything for you so that you don't have to digest it all at once, of course. I don't expect that everyone would be able to understand all these details all at once. What's more important, really, is to understand the general principles of how something like pleasure and pain work, how they interact, and the various cells and systems within the brain and body that allow them to occur and that modulate or change their ability to occur, and of course, your subjective experience of pleasure or pain. So I do hope that this was, on whole, more pleasurable than painful for you. If you're enjoying this podcast and you're learning from it, and you'd like to support us, you can do that in a number of different ways, some of which are totally cost-free. The first one is please subscribe to the YouTube channel. That really helps us. In addition, you can leave us comments and suggestions for future podcast episodes on the YouTube channel. You can also subscribe on Apple and or Spotify, or all three. That would really help us. And on Apple, you can leave us up to a 5-star review and leave us feedback. There are other ways to support the podcast as well. We have a Patreon. That's patreon.com/Andrew Huberman. And there you can support the podcast at any level that you like. In addition, please check out our sponsors that we mentioned at the beginning of the podcast. We only work with sponsors and brands that we absolutely love their products and that we wholeheartedly endorse and that we use ourselves. In addition, we've partnered with Thorne. Thorne is a supplement company, and we've partnered with them because they have the highest levels of stringency in terms of the quality of the ingredients they use and the quantity of the ingredients they use. By quantity, I mean that unlike a lot of supplement companies out there, the amounts that are listed on the bottle are absolutely what you find in those capsules and tablets in the bottle. If you go to Thorne, that's THORNE/U/Huberman, you can see the supplements that I take, and you can get 20% off any of those supplements as well as any of the other supplements that Thorne makes. Just go into the Thorne site through that portal, Thorne/U/Huberman, and even if you navigate off from that location in the site, you'll get 20% off any of the items that you might select from other locations within the Thorne site. If you're not already following us on Instagram, it's Huberman Lab at Instagram, and there I do various tutorials about neuroscience, offer neuroscience-related tools, all backed by science. And last but not least, I thank you for your time and attention, and thank you for your interest.
How many other people really want to mate with this person? That's a good cue that they're high in mate value. Nobody wants to mate with you, then cue that you're low in mate value.
Reminds me of the time when one is trying to decide who to ask to the prom. You know, there's a complicated assessment based on who one would like to go with, whether or not you're already partnered, who would say yes, who would say no, because there's a risk in rejection too, because
yes.
That, if I'm guessing correctly, could lower one's own perceived mate value.
Getting rejected.
Right. Frequency of rejections probably doesn't lend itself well to increasing one's own view of their mate value.
Right, which is why many guys have what I call mating anxiety. That is, they don't approach women because they risk getting shot down.
They're trying to maintain that number by reducing the amount of data.
Right.
Yeah. Very interesting.
But it backfires in the modern environment. So there's a famous psychologist, Albert Ellis, who had mating anxiety, and he assigned himself the task of asking, like, I can't remember what the number was, but let's say 50 women out on dates. He lived in New York City, so there were a lot of women.
He could just stand still and they would stream past.
And he assigned himself, like, ask 50 women on a date, every week. And he said after 2 weeks, his mating anxiety disappeared, because most of them said, buzz off, creep. But he decided, well, actually getting rejected didn't cause my world to collapse, and it actually was okay. And so he kind of inured himself to this rejection. And so he ended up doing quite well in his mating life.
Another point for cognitive behavioral desensitization.
Yes, exactly.
He ran the experiment. Just a couple more questions. Earlier, you mentioned self-deception-based deception, or something of that sort, self-deception, that people aren't always trying to convince somebody else of something that secretly they know isn't true, but that they deceive themselves. Could you embellish on that a little bit?
Yeah, so, this is actually, this hypothesis is the famous evolutionary biologist Robert Trivers first advanced this hypothesis in the preface in 1976 to Dawkins' book, The Selfish Gene. And he's subsequently written more about it, both in scientific article and in a more popular book. But the idea is that the core idea is that successful deception is facilitated by self-deception. So if you really believe that in X, then you're going to be a more successful salesman to convince other people of X. So if you believe you're, let's say, a 10 in mate value, you truly believe it, even if you're not, I'm going to have a more successful time convincing you that I am as well. And so the hypothesis is basically that people self-deceive in order to increase the effectiveness of actual deception. Okay, but I think that there are people who are so. In one other dimension I'll mention too is that animals often take each other at our own word for things. So if we're self-confident, people assume that we must have the goods to back up that self-confidence. If we're a quivering mass of insecurity, people believe, well, we don't have the goods to back up anything, And so people use other people's displays of their self-confidence as a cue to their goods. And it's, in general, a pretty reliable cue, but then there are overestimates and underestimates, as we've talked about, like with narcissism.
Yeah, we see this with the job candidates. You are taught to look very carefully at the application and consider all aspects, but ultimately you consider that also in light of how firmly someone believes in the vision of what they're trying to bring to the profession.
Yeah,
and that's I think largely a subconscious process, and being aware of it can be helpful. But yeah, when somebody's confident, you tend to think that they're going to get where they say they're going to go, and it acts as a bit of a heuristic for not needing the impulses that one then doesn't need to go vet all the information quite as carefully. But if one is aware of it, then to dig deeper in because it seems like there's a lot of deception going on.
Yeah. Well, something we talked about earlier, people high on psychopathy are very good at deception. I don't know whether they are good at self-deception or whether they're just really good deceivers, So, but they can be very effective. And out in California, you live out in California. I'm sure you've seen your fair share of cases like that.
Oh yeah, I think across today's discussion, and various examples pop to mind of seeing these features in humans. It's so interesting. I find the work that you do incredibly interesting. I think this field of evolutionary psychology is fascinating, and I hope I said it before, but I'll say it again. I feel like neuroscience and evolutionary psychology are nudging towards one another. Absolutely. And it's only a matter of time before they merge in some formal way. I mean, there is the work, for instance, on polygamous versus monogamous prairie voles and levels of vasopressin, but it's a big leap to go from vasopressin in a prairie vole, disrespect to that beautiful work, but to humans and say, vasopressin inhalers are going to make you monogamous or something. Yeah. I think that's I probably got the direction of the effect wrong, but you get the point.
I think you're absolutely right. And I think it will happen. I think it's starting to happen, and it will happen because getting at the neuroscience is getting at the underlying mechanisms that are driving the process. So, what an evolutionary perspective brings to bear is evolved function and ultimate explanation, the selective forces that created adaptations, the functions of those adaptations. And the neuroscience brings, what is the underlying machinery that these mechanisms are instantiated in?
Yeah, it would be wonderful to collaborate someday. Maybe we'll do a brain imaging study on jealousy or something, and I don't know, and throw it. You're the psychologist. You would come up with the beautiful experimental design. I'm certain that people are going to want to learn more about your work. Certainly, we will give them links to your social media and other sites. You've written a tremendous number of really interesting books. Tell us about your most recent book and maybe some of the others that if people are interested in these topics and they want to learn more that they could explore.
Sure. Okay, so, my most recent book is called When Men Behave Badly, The Hidden Roots of Sexual Deception, Harassment, and Assault. And that book deals with conflict between the sexes, sexual conflict. And so it deals with them both in what I call mating market conflict, so some of the topics we've been talking about, deception in internet dating and things like that. Second is conflict that occurs within mating relationships of the sort that we've been talking about as well: financial infidelity, emotional infidelity, sexual infidelity, coping with conflict within a relationship. And I actually have some suggestions for strategies for coping with conflict within a relationship. Coping in the dealing with the aftermath of breakups. So often there's an asymmetry. One person wants to break up, the other doesn't. So I talk about coping in the aftermath. And then I also talk in this book, When Men Behave Badly, about some of the darker sides of human mating, like intimate partner violence, stalking, sexual harassment, sexual coercion. So that's what that book's about. And I think it's gotten well reviewed, and people find it very useful in understanding what is otherwise a lot of baffling phenomena. Why do men and women seem at odds with each other in so many domains? Why do some of these recurrent forms of sexual conflict occur. So that's what that book's about. My previous book, so my first book, which I've had the good fortune to be able to revise a couple times, deals more broadly with human mating strategies. It's called The Evolution of Desire, Strategies of Human Mating, and gives people a broad overview of what people want in a mate, tactics of attraction, tactics of mate retention, and so forth throughout the whole mating process, serial mating, causes of divorce, and so forth. And then even more broadly, I have a textbook called Evolutionary Psychology, The New Science of the Mind, which is in its 6th edition right now, and it's the most widely used textbook in evolutionary psychology around North America and Europe, and actually it's been translated even into Arabic and other countries. So that deals somewhat with mating, but also deals with survival problems or evolved fears and phobias, issues about kin and family, extended family, friendships, social hierarchies, status hierarchies, warfare, and other topics. So the evolutionary psychology textbook is the broadest book, and then maybe the second broadest is The Evolution of Desire, Strategies of Human Mating. And then for those interested in conflict between the sexes, the latest book, When Men Behave Badly.
Fantastic. I love your work. I'm so grateful for the clarity and depth and rigor with which you do it, and you convey it to us. I know I speak for many people when I just want to say thank you. This is a tremendously informative conversation.
Thank you. Well, it's been a delight to talk with you, and I hope we do engage in that research collaboration of merging neuroscience and evolutionary psychology.
Let's do it.
All right.
Great. Thank you, David.
Thank you.
Thank you for joining me for my conversation with Dr. David Buss. Be sure to check out the link to his website in the show caption, and be sure to check out his new book, When Men Behave Badly, The Hidden Roots of Sexual Deception, Harassment, and Assault. If you're learning from and or enjoying this podcast, please subscribe to our YouTube channel. That's a terrific zero-cost way to support us. In addition, please put any questions you have in the comments section on YouTube, and also in the comment section, you can make suggestions about future topics for the podcast or future podcast guests that you would like us to host. Also, check out our sponsors mentioned at the beginning of the podcast. That's one of the best ways to support us. In addition, please subscribe to the podcast on Apple and or Spotify. And on Apple, you can leave us up to a 5-star review, and you can also provide us questions and feedback. We also have a Patreon. It's patreon.com/Andrew Huberman. And there you can support this podcast at any level that you like. In many episodes of the Huberman Lab podcast, we discuss supplements. While supplements might not be for everybody, many people derive tremendous benefit from them for things like sleep and focus and other aspects of human performance in daily life. One issue with supplements is that many of the supplement companies out there are subpar with respect to quality, and they are not precise about the specific amounts of the various supplement contents that they include. For that reason, we've partnered with Thorne, Thorne, because Thorne supplements are known to have the highest levels of stringency in terms of the quality of the ingredients and the precision of the amounts of the ingredients. In other words, what's listed on the label is what's actually in the bottle. If you want to see what supplements I take, you can go to thorne.com/U/Huberman. There, you can see the supplements I take. You can get 20% off any of those supplements. And if you navigate further into the Thorne site through that portal, thorne.com/U/Huberman, you can also get 20% off any of the other supplements that Thorne makes. Thank you once again for joining me for my discussion with Dr. David Buss about human mate selection and strategy and many other extremely interesting topics today. And last but not least, thank you for your interest in science.